All right, concept 29 is solving linear inequalities. Now, the cool thing about these inequalities is that they're the same as solving regular equations. You'll notice that the problems on this page they don't have equal signs, they have inequalities, but solving them is exactly the same except for one exception. So, the steps to solving inequalities are the same as solving an equation with one exception. And that exception is that when I am multiplying or dividing on both sides of an inequality by a negative number, specifically a negative number, I must flip the inequality sign. I must flip the inequality sign. So similar to what we did, we're flipping in, I think, concept 27. It's very similar. So let's try it out. Just as a quick review, when I see this, actually, let me do a little lower. When I see this, I do this, okay? So when I see addition, I do the opposite. I do subtraction. When I see subtraction, I do addition. When I see multiplication, I do the opposite. I do division. And when I see division, I do multiplication. So we're going to use those rules, and we're going to practice some of these problems here. So make sure you get these down on your paper, because this is like key to understanding this lesson. So let's try out number 1. It says I have negative 6x plus 5 is less than or equal to negative 7. Now remember, I want to get x by itself. I'm going to get rid of the 5 first. And since I'm adding, I'm going to subtract to get rid of it. And of course, I have to do that on both sides. So 5 minus 5 is just 0. So I'm left with negative 6x is less than or equal to negative 12. Now, my inequality symbol stays the same because I didn't multiply or divide by a negative number. I subtracted, but that doesn't change my inequality. Now, here, in order to get rid of the negative 6, since I'm multiplying, I need to divide. Now, when that happens, I know that I need to switch my inequality because I've divided by a negative number. So right off the bat, I'm going to flip my inequality, change directions, and negative 6 divided by negative 6 is 1, so those essentially cancel each other out, and I'm left with x. And on the right side, I have negative 12 divided by negative 6. I know negative divided by negative is positive. My x is equal to 2. So I divided by a negative, so I had to flip my sign. But other than that, I'm solving equations just like I normally would. This is no different than what we've done before. Let's try again with another problem. So I would add 8 to both sides here since I'm subtracting. So now I have 7y is greater than 55 plus 8, which is 63. And again, my inequality symbol doesn't change. I'm now going to divide on both sides by 7. And the 7s cancel each other out, so I'm just left with y. And my symbol doesn't change. Oops. My symbol doesn't change because it was positive. And 63 divided by 7 is 9. And that's it. That's it. Let's try again. So I have a little bit of some extra steps here. I want to make sure my p terms are on the same side and all the other numbers on the other. So first I want to add 2p to both sides. 2p here and 2p here. So I have 9p plus 8 is less than or equal to negative 10. Okay, so it's, again, just like a normal equation. Symbol stays the same. I'm going to subtract 8 on both sides. So I have 9p is less than or equal to negative 18 now. And again, not changing my inequality. And I'm dividing by 9. So p is less than or equal to negative 2. Again, symbol didn't change. Solve it like a normal equation. Just keep the symbol the same. Let's jump to number 5. Now this one looks like it's going to be a changing situation. So first I want to get my 13 away. I want to move it, so I'm going to subtract. Since 13 is positive, I need to subtract to make it go away. And I need to do it on both sides. So now I have negative 5x is greater than or equal to 15. Symbol didn't change, everything's fine. Now I have to divide by negative 5 and divide by negative 5. And I know that when I divide by a negative number, my inequality symbol changes direction. So it becomes this. And then I just bring my x down because negative 5 and negative 5 cancel each other out. And 15 divided by negative 5 is negative 3. But I have switched my symbol from greater than or equal to less than or equal to. And number 7, you'll see that it looks like a bit more complicated, but it's, again, solving it just like we did before. Use a distributive property, combine like terms, put the variable on one side, and whatnot. You're gonna get the same, you're gonna be able to solve it just like you would a normal equation. And that's that.